Okay, last one. So problem 6, where we have this cop and the speeder, and come on. Okay, there we go. This cop and the speeder. So, oh, the kitties are getting restless. Okay, so this is a tricky problem. What happens is the cop sends out some electromagnetic waves which travel at the speed of light, c. I've seen a lot of people using the speed of sound. No, radar is not sound. Radar is light. So c is the speed of light, and the cop sends out these waves. The speeder is moving away at a speed of v relative to the cop. First point to note here is that you don't need to worry about the absolute speed of the cop and the absolute speed of the speeder. All you need to worry about is the relative speeds of the two. One reason why is because the speed of light is so huge that it doesn't matter. As long as you get the relative speeds right, the math will come out, close enough that you won't notice. The other reason is actually because Albert Einstein said that, in fact, the speed of light is invariant in all reference frames that are not accelerating. So the point is, you can do this. You could also do it equivalently. You could do it with the cop moving away at a speed of v and the speeder being stationary, and that's probably, now that I think about it, the easiest way to do it. But I've already written out the hard way, so let's do it. So the cop puts out waves at a frequency of f0, and they arrive at the speeder at a frequency of f1. The speeder's going away, and so this is just applying the canned Doppler effect equation you can find in the book. When they return, the speeder is effectively, it's as though the speeder is broadcasting them again at the frequency he received them. Okay, he's just reflecting them, really. He doesn't know he's doing it, of course, but unless he's got a radar detector, but we won't go there. So he's just returning the waves at the same frequency he heard them at, quote, heard them, I guess, and so then the cop, hears them at f2, and this is again an application of the canned equation. Both cases result in the waves being shifted downward toward a lower frequency. So both of these, you'll notice, because c and v are both positive numbers, both of these equations, the factor in parentheses is less than 1. Okay, so f2 then is what the cop finally hears, and so I'm going to say f2, I'm just going to plug these two together, equals, and then c minus v over c times c over c plus v times f0. Okay, and then of course these cancel, so what you get is f2 equals c minus v over c plus v times f0. Okay, now let's see, where do we go from here? This is where it gets a little tricky, and people have questions about whether it's okay, because with the sig fig issue, you're taking c, which is a huge number, and then you're adding or subtracting the speeder's speed. And you don't know how fast the speeder's going yet, but it's pretty clear he's not going anywhere close to the speed of light, right? So this is where it gets sneaky. And so what do you have to do? Now I'm trying to remember. Let's see. So I think what you do, I mean, one thing you can do is just say, what are we trying to find v? Crap. Now I'm having trouble figuring this out. Unbelievable. I guess the way I would go from here is... Holy crap, how did I make this problem so hard? The way I would go from here... I don't know. There's no easy way to go from here. I sort of painted myself in the corner. There are probably easier ways to do this problem. But I'm going to multiply top and bottom here by c minus v. So f2 is c minus v times c minus v over c minus v times c plus v times f0. And now you're like, what the hell does that get you? Well, this on the top is c minus v squared, and on the bottom you get c squared minus v squared because of that whole a plus b, times a minus b equals a squared minus b squared, that whole thing from algebra. So, okay, so then what I can say is V squared is going to be super duper tiny compared to C squared. Like way tinier relative to C squared than V is relative to C. So I can just neglect that. But this is playing fast and loose. I don't really like doing this with you guys. I mean, I don't really like... Crap. Well, it is what it is. Alright, so F2 equals C minus V over, and that's squared, over C squared times F naught. And then, so then you can get it to C minus V over C quantity squared times F naught, which equals 1 minus V over C quantity squared times F naught. Oh, I still don't like it. Wow, this is not nice. It was wrong of me to try to do this to you. Okay, so F2 equals 1 minus 2V over C, okay, plus V squared over C squared times F naught. And so the V squared over C squared is super duper tiny compared to the rest of these terms. And so F2 is going to equal F naught minus 2V over C times F naught. Okay, and that equals F2. I'm just trying to bring this full circle. And so what I'm going to do is take this guy and subtract out, yeah, okay. So F2 minus F naught equals, oh wow, okay, yeah, 2V over, yeah, okay, negative 2V over C times F naught. And so, blah, okay, so F2 minus F naught is that change in frequency we saw earlier. Okay, so what they said was 322 hertz. So I'm going to call that delta F naught. And then delta, okay, sorry, not A. No, not delta F naught, just delta F. And that's the 322 hertz change they mentioned. And so that's going to, or I mentioned, to be fair. And so that's going to be negative 2V over C F naught, right. Negative 2V over C times F naught. So F naught is your 6.88 gigahertz, and this is your 322 hertz. So let's see, how do I do this now? So I guess now what I say is V equals, and that's the speed of the speeder, so I'm just going to do negative, holy crap, okay, delta F over F naught over 2 F naught times C. Wow. Okay. So, well, okay. So, let me try that again. I'm just going to try this. Delta F over 2 F naught times C. And so that is going to be negative delta F is negative 322 hertz over this 2F naught, which is 2 times 6.88 times 10 to the 9th hertz. And then this is going to be 3 times 10 to the 8th meters per second, 3.00, whatever. So it's going to be like 966 over something. I think it'll work. Yeah, so it'll actually come out to, does it really? Yeah, so it comes out to like, wait, does it? Is it 2 screw things up? 1/2. Oh, you know, I don't know. Yeah, it does. I think it works. And it's going to come out to like, so this is going to, let's see. Man, I have no enthusiasm for this problem anymore. Which is probably how you guys feel about this entire class at this point, but hey. 300 for... No. 1 over... I don't know, whatever. I think it works out right. The answer is V is around 50.5 kilometers per hour. Now remember, this was the speed of the speeder minus the cop. And so the cop is going 100 miles an hour, so that means the speeder is going, sorry, not 100 miles an hour, 100 kilometers an hour. The speeder then is going 50.5 kilometers per hour faster. So VS is about 150.5 kilometers per hour. I'm pretty sure that works, but let's see. No, I don't care. Wait, I care a little bit. So 500. It's not going to work. 1.5 times 5. 7, 4. I think it works. I think it works. I'm just going to say it works, call it a day, and play with the kitties. Okay, so anyway, ask me if you have questions. Of course, good luck with the test tomorrow or Friday.